Hello, and thank you for tuning in. Today we are going to talk about high voltage power supplies and some capacitors. I have no idea what I'm doing, but I don't care. So, to give you a little bit of detail about my high voltage experiments, I have two capacitors at DC that are connected to a high voltage power supply over this BNC cable. I have taken those in parallel, so I have bigger capacitance, and right here I have a little resistor, and this is a 1 mega ohm resistor because I only have 1 watt resistors, and if I take a lower resistor the power would be too high and it would fry the resistor. It would be optimal to take a lower resistor too, because the value of this basically sets your charging current and your charging time with this. So it will take a long time to charge. If I take a lower value and bigger power rated resistor, I will be able to charge this a lot faster, and that's what I'm going to do at some point, because I want to control this with an SCR, a silicon controlled rectifier, and this is basically a big diode which can be current controlled by these two leads. So I can switch the 1200 volts or 1500 volts, which goes in at the case and out at the cable, by applying a voltage or a PWM signal to here, and then I can use this for charging, but this will be for a later episode. Yeah, for charging I use this Fluke415B high voltage power supply. Those are not too expensive on eBay or something, like 200 bucks. I found this in a dump, so it was pretty free. I was very surprised it worked because it has some tubes in it. I will probably do an overview of it because it was very well documented on the internet. So we might do a little tear down, or maybe open it up and look at the things, compare it to this to the data sheet, because all the PCBs in there are labeled and all these schematics are in the manual actually, because it's a very old power supply. You don't see this nowadays very often. It goes to 3 kilovolts. Focus. So it goes to 3 kilovolts plus or minus. You can switch this here, plus, minus, minus, plus. You can switch the polarity to ground, the high voltage polarity to the ground. Here you can set the voltage. It's like course is 1 to 2500. If you want more, you can go to 100 volt steps. You can go to 3000. Like this configuration would be 3000 to 5 plus 500, and then you can do some small increments of 10 volts, 1 volt, and then 0.1 volts. So you can set a pretty precise voltage with this. I will do here everything 0, 0, 0, because the capacitors are 1500, so we won't go over that. Maybe we will start with 1000 volts and then maybe we will go to 1005. Or if we use the silicon rectifier, we will probably only go to 1200, because the rectifier is rated for 1200 volts. So 1.2 kilovolts, and I don't think it will handle 1500, but maybe we'll see. I have 2 of these rectifiers, so maybe we will test one to the limit. Then here I can switch on power, then this lamp will come on, and that means the power supply is started, is on, but there is no high voltage. For this you have to wait 30 seconds for the vacuum tubes to warm up, and if they are warmed up, when they are warmed up, like 30 seconds after, I think in there is a little timer relay, and it's also a tube, and it will tell you when the high current, high voltage switching tubes are ready. So if this one is lit, we can switch there, and the BNC connector will output whatever voltage you set there. You can switch this if it's on. I don't know if it's a good idea, but I've done it. It didn't kill everything. This power supply has a max current of 30 milliampere. This will be sufficient for charging this capacitor a little bit or something. It's not very much. It should not be deadly. I wouldn't touch it because it's very borderline of being not very It is dangerous, is what I wanted to say. You can actually die by touching the wrong leads, especially with the capacitors, because the capacitors, they store a lot of energy, and if this energy is released in one little boop and your heart is in between that, it's probably going to, you cannot overclock yourself. Stop. Exactly, so I don't recommend touching it. Yeah, I had to replace the cable because it had like exposed leads on there, so I just shortened it to the point I needed, and then I had to glue in something. You can see a little cap on there, here on the tube. That's where the high voltage output sits, and this one broke off, so I had to glue it back on, but now it's working flawlessly. So I think we will just start, and yeah. So yeah, let's power it on. So I have set it on 1000 volts. Now I will turn it on. You can still adjust this. If this is on, that's okay. I would not adjust it if high voltage is on. It works, but I would not. I have to plug this in still. Here is my capacitor setup, as I explained earlier. Nothing special. And you can see the light went on. Standby reset is good. So I will switch to high voltage. Now the cap is charging. And yeah, we can leave this for a few minutes and then I'll be back. Just to let you know, we won't be doing something very interesting. I will just be discharging the capacitor with some aluminum foil. Yeah, I mean, it's pretty basic and simple, but that's the start. I think we are now charged enough. We could probably get some more power in there, but I think that's enough for now. Now it's ready again, but no voltage, because if I put it on, you can see it goes to 1000 volts. It's charging, but I will put it out, and then I will also unplug this. It probably has some reverse voltage protection, but I don't want to risk getting a high voltage shock into this machine, possibly breaking it. So this should be charged with 1000 volts. I have no idea because I cannot measure this directly. Maybe with the oscilloscope and the 10x probe. I have to read about that. But we will try to discharge it now. Oy. This was louder than I expected. Probably because I never put those in parallel. I always put them in series or something. Or I just took one of those. I didn't expect that. But yeah. You can also probably see, I don't know, here. You can see it was enough power to rip the aluminum foil and melt it partially. It looks pretty burnt. I will blend in an actual nice picture. so you can see. Yeah, this was 1000 volts discharged in 1 millisecond or something. I don't know, but it was very fast, because now there is no charge left in there. Now the next step would be to connect this, so we will be able to control our pulses electronically from a safe distance and not with a stick. But now it's discharge time. So this was my little video about charging the capacitors and playing around with some high voltage. I will do a follow-up video as soon as I get the SCR working, because that's the next step. I will probably use this for magnetron sputtering at some point, so I want to do a high frequency pulsed DC generation with this. But yeah, I think we will get there along the way. First, next step SCR, then next step introducing some high frequencies. So thank you for watching. Like, comment, subscribe if you want to see more of this shit. I have literally no idea, but that's the nice thing about learning. And if you have something to say or something to ask, just feel free to tell me. I like inputs and I like comments, and yeah, until next time, bye bye.